the second movie for section 5.1. In this particular section, we're looking at consumer surplus and producer surplus. In this particular video, we're going to look at price ceilings, price floors, and deadweight loss. These are three very important ideas in economics. We'll take them one at a time. First off, a price ceiling. As the name implies, and as you're accustomed to thinking about ceilings, a ceiling is something that's overhead. It's as high as the room reaches. A price ceiling is as high as the price is allowed to go. A price ceiling is established in a situation where you have an equilibrium price, but this equilibrium price is, by some determination of a group or a person, too high. A lower price ceiling is then set to prevent the price from reaching this higher level. An example of a price ceiling is the rent control that occurs in New York City. In New York City and the various boroughs, the local governments there establish price ceilings on the per square foot rental price of an apartment. If it was not for these rental prices, the price would go from this ceiling up to an equilibrium or demand price, which would be a problem because teachers, firefighters, and policemen are required to live within the community where they work. But they would not be able to afford the higher rent prices. Because they cannot reach these higher prices, and the local governments see it as being desirable for them to be able to live in the neighborhoods where they work, they establish rent control or a price ceiling where the price is set lower than what it would settle in at if it was allowed to reach an equilibrium. Let's take a look at what happens with a price ceiling. First off, the price ceiling, P sub C, is always going to be less than the equilibrium price. The objective here is to create a savings for the consumer. What's going to happen is there's a trade-off. At this equilibrium price, the consumer would gain all of this area up here, both the top part of the orange as well as the top part of the blue. Okay. However, when a price ceiling is established, because the price is lower, you wind up with less units being available because the producers aren't willing to provide as much, or isn't as much income. It's not as attractive of an investment for them. As a result, you only have this many units now available instead of the equilibrium number of units that we originally had available. When you establish this lower number of units, as a consumer, you still realize this consumer surplus. You do not gain this because these units are no longer available. They aren't there at all because the producers aren't willing to provide them. The objective in this scenario is there is some consumer surplus that's lost, this area. But the objective is they gain this additional area, this rectangle here. And the hope is that the amount of savings gained in this rectangle will exceed what was lost in this triangle. So it's kind of a delicate balancing act. You've got to pay attention, or you can actually wind up by setting the price low, not having enough units available to meet the need, and the consumer not benefiting in the long run. When you go to compute this new consumer surplus, what's going to wind up happening is you want to compute widthwise from 0 over to x sub c. So in the x direction, the width of this unit is going to be from 0 to x sub c. Okay, so we're going to have from 0 to x sub c, and we're now doing the area underneath the consumer function. Okay, so that's going to be our demand function, d of x dx. And we need to be mindful of the fact that the consumer does not get everything that is underneath the demand function. Recall that the producer gets this area here, or the producer, and yeah. So what's going to wind up happening is we're going to have all of the area underneath the demand curve minus this blue area down here. To compute that area, it's a rectangle that is x sub c wide and p sub c tall. So you're going to wind up with the area of that being x sub c times p sub c. Using similar reasoning, we can compute the formula for the area of the producer surplus. Okay, the producer surplus is now going to be this green area. This area, as above, is only going to extend over to x sub c. It's not going to go all the way over to the equilibrium quantity anymore. And what we're going to want to focus on is computing the area of this green shaded portion here. In this particular graph, it's a triangle. It won't always be a triangle. It depends on the shape of the supply function. If the supply function is a straight line, you get a triangle. If the supply function is not a straight line, you don't get a triangle. Okay, so what's going to wind up happening here is we're going to wind up with our producer surplus being the entire rectangle. And remember, what we're really after is the green part. So we start out with the entire rectangle. So that's going to be x sub c, p sub c. And from that, we're going to subtract this white shaded region here. Well, that's the integral from 0 to x sub c. That's the width. This is going to be our supply function, dx. The producer and consumer surplus formulas are very similar to what we used in the Part 1 movie. The only difference being that we are now changing our limits from our equilibrium quantity to a ceiling quantity, from our equilibrium price to a ceiling price. So we're just making adjustments to compensate for the new level of demand, the new level of production. There is a third area that comes into play. Notice that when you implement a price ceiling, the consumer gets the orange part. The producer gets the green part. However, there is this area that was originally here at the equilibrium that's now lost. This is called the dead weight loss. To compute the dead weight loss, what you wind up doing is you want to integrate. Now be careful, catch this. It starts at the ceiling quantity, so it's going to be x sub c. It's going to go up to the equilibrium quantity, and if you'll recall, when we were doing areas between curves, you take whichever function is on top. Well, in this case, that's going to be the demand function. From that, you subtract the function that's on the bottom, in this case, the supply function, and you integrate that. Okay, so what's going to wind up happening with our dead weight loss is we're going to get the integral from x sub c to x sub e, our supply function minus our demand function. You need to be aware of all three of the formulas that we've just gone through. Okay, and they're listed for you over here on the left-hand side. Be sure that you understand and can use all three of these. Next thing we're going to do is we're going to look at a price floor. See if I can change the ink color. here. As the name implies, a floor is as low as it can go. There are situations where, once again, government will intervene and create a price floor. One example of this is sometimes with agricultural goods, for example, milk. Okay. The government will sometimes step in and say milk cannot sell below this much per pound. It may sound odd hearing the term pound, but when it's actually initially sold and purchased, it's in terms of pounds, not in terms of gallons. Okay, so what winds up happening is, if you have a price floor, you would have an equilibrium price here. But what the floor is going to do is it's going to raise the price to some artificially high amount, and in raising the price, the objective is to benefit the producer. The reason the government is trying to benefit the producer with regards to milk is they're trying to make sure that the dairies stay in business. If the price drops too low, can't afford to produce it, and dairy farmers go out of business. Okay, let's compare a price floor scenario to a price equilibrium scenario. In the price equilibrium scenario, the producer gets the lower half of the green as well as the lower half of the blue. This is all the producer surplus. In a price equilibrium scenario, the consumer gets this whole top half. As soon as a price floor is implemented, both sides lose out on this blue triangle area, because with a price floor, only this many units wind up being purchased. Notice I said purchased, not produced. The reason that we're talking about purchasing is because as the price goes up, it is the consumer who's going to make the decision of how much demand there really is for that product, and it's not based on the willingness of the supplier to create more of it. Okay? So what's going to wind up happening, as with the previous scenario, is this blue triangle is going to be lost, part of it to the consumer, part of it to the producer. The objective is, as before, the producer is going to gain this new green rectangular area, and the hopes is that new green rectangular area exceeds the blue triangular area that they're losing. The objective here with a price floor is to get more money to the producer to support them. Okay, so let's take a look at what happens for the consumer surplus in this case. The consumer surplus is going to be the orange amount. That's going to be up here. So what we're going to wind up doing is we're going to compute all of the area underneath, and that's going to be the integral from 0 to the quantity at the floor price, and it's going to be whatever the demand is. Then what we need to do to get just the orange area is we need to subtract off this whole area here. Well, this area here is going to be a rectangle with a width based on the number of units at the floor times the price at the floor. So this looks very, very similar to the consumer surplus that we did earlier. The only difference is we're changing our upper limit, and we are changing the values for the rectangle. In the case of the producer surplus, it's going to work out very similar to what was done before, with some minor changes. Once again, we want the area below the price line. And to compute that area below the price line, what we can do is to compute the entire area. This entire area for this new producer surplus is going to be whatever the quantity at the floor price is times the floor price minus, then what we're going to do to get the green area is we're going to subtract off this white area. Remember, the white area is an area found by integrating, because integrals provide areas, and it's found by integrating from 0 over to the floor quantity, integrating with respect to the supply function. In addition to computing the producer surplus, there is a third computation that needs to be done, as was done earlier, and this is the dead weight loss. The dead weight loss is surplus money, savings if you would, or gains in the case of the producer, that's lost. It's lost because we've moved from an equilibrium quantity to a floor price, and we've moved from an equilibrium price to a higher price floor. Okay. So the third thing we need to do is we need to compute the dead weight loss. I'll abbreviate it DWL. As we looked at with price ceilings, with a price floor it works the same. We want the area that is enclosed between the demand function and the supply function. So we're going to integrate from the starting point, which is x sub f, integrate all the way over to x sub e, and we're going to do our demand function minus our supply function, and that will then allow us to compute the dead weight loss. Okay, so there are three things you need to be able to compute, whether it be a price ceiling or a price floor. You need to be able to compute the consumer surplus, the producer surplus, and the dead weight loss. Each of these is done after you first compute the new quantity and the new price. Typically the price will be given to you. Let's take a look at an example of how this would work. The example that's provided in your book on page 476 reads, in a small isolated mountain town, demand for propane is given by this function here, and supply is given by this function here. X is in gallons per month per customer. D of X and S of X are dollars per gallon. First thing we're asked to do is to compute the equilibrium price. Well, recall that the equilibrium price occurs where the demand is equal to the supply. The demand equal to the supply would say we have 6.50 minus 0.25x is equal to 2.10 plus 0.15x. These equations came from the demand side of the problem and the supply side of the problem. At this point, it's a matter of just solving this algebraically. Add 0.25 to each side and we'll get 0.4x equals, subtracting 210 from each side, we'll get 4.40. When you divide both sides by the 0.4, you get x equals 11. Now, before we go any further, it's important to determine what this x equals 11 really means. And if you read in the problem itself, you'll note that x is the gallons per month per customer. So what this is saying is, if we establish the selling rate as being the equilibrium price, we'll wind up with each customer on average purchasing 11 gallons per month. We know the number of gallons. What we need to do is we need to determine what the equilibrium price is going to be that will facilitate the sale of 11 gallons per customer. Well, this equilibrium price can be determined by substituting x equals 11 into either the demand function or the supply function. We'll work it out with both of them so that you can see it works out to be the same price either way. We have 6.50 minus 0.25 times the x value, which is 11. If we look at the supply side, it's going to be 210 plus 0.15 times 11. And in either case, we get an equilibrium price of $3.75 a gallon. The $3.75 being in terms of dollars per gallon. So this tells us if we allow things to run and an equilibrium price and an equilibrium demand to be established, at $3.75 a gallon, each customer will wind up purchasing 11 gallons a month. Now, the advantage to a scenario like this is both sides are receiving the maximum benefit. If you, by maximum, I mean if you had the benefit to the producer plus the benefit to the consumer, the total amount of additional money in the system, okay, is going to work out to be the highest. Okay, we're asked to compute now the consumer surplus and the producer surplus at the equilibrium point. Well, let's remember that the equilibrium quantity is 11 gallons. The equilibrium price is 3.75. And let's do the consumer surplus first. Consumer meaning demand function. Our demand function is going to be the 6.5 minus 0.25x. To compute the consumer surplus, what we want to do is we want to do the integral from 0 to 11, and we're going to integrate the demand function, 6.5 minus 0.25x dx. From that, we're going to subtract off the rectangle at the bottom. Remember, what we're dealing with in this case is we want this top part. This top part comes about by integrating underneath this line and then subtracting everything in this rectangle. That rectangle, as you'll recall from the first movie, is actually the total revenue generated. So what we're going to wind up doing here is we're going to subtract off the equilibrium quantity times the equilibrium price. On quizzes and tests at this point, I will just assume that you're going to write down the equation that you're going to evaluate and then just work it out in your calculator. Okay. So what we're assuming here is you're just going to work it out in your calculator, and when you do that, this particular consumer surplus now works out to be $15.125. Now remember, that doesn't really make a whole lot of sense if you're trying to actually pay that. So we're going to round this off to be approximately $15.13. This extra half a cent we'll see coming back in a little bit later. Okay? And we'll talk about it at that point. That extra half a cent is going to come into play. Okay? And we'll explain that away later because of the rounding. Okay. Let's compute the producer surplus. Once again, we're going to use an equilibrium quantity of 11 gallons. We're going to use an equilibrium price of $3.75. And we're going to use the supply function of 2.1 minus 0.15x. Recalling in this case that the producer surplus is this amount here, what we're first going to want to do is to compute this entire revenue. The entire revenue is going to be the equilibrium quantity times the equilibrium price. From that, we're going to subtract. And what we're going to subtract is the area underneath the supply curve. Well, that area underneath the supply curve is going to be the integral from 0 to 11. Then we're going to integrate our supply function, 2.1 minus 0.15x dx. As with the previous slide, I will assume on quizzes and tests two things. I'm going to look for or assume that you're going to give me a clear definition of what you're evaluating in your calculator. That clear definition being that equation there, with the limits of integration, the equilibrium price, and the equilibrium production all clearly identified. You can go ahead, run it through your calculator, and if you run this through your calculator, you're going to get 9.075, which in this case is going to give us 9.08 rounded off. As with the previous slide, where we discussed the fact that in the rounding we were ignoring half a cent, okay, or actually we're throwing in an additional half a cent. In the last one we also rounded up, so in the last one we added half a cent to the system. In this one we are also adding half a cent to the system, so we're going to wind up with an extra penny somewhere along the line, and we'll see that later. Alright, assume a ceiling price of $3 per gallon of propane is imposed. So what winds up happening is that whatever level of government decides that the customer shouldn't have to pay more than $3 a gallon. So it's a ceiling. That means the price can't go any higher than a given amount. So what we're working with now is originally we had a scenario where this was our supply function. This was our demand function. We had an equilibrium price and an equilibrium quantity. With a price ceiling, it's going to set things down lower. And by setting it down lower, it's going to reduce the number of units available. The number of units available is going to be smaller than the equilibrium number of units. First thing we're asked to do is to compute what x sub c and p sub c are. Well, first off, notice we're already given the ceiling price. The ceiling price is $3 a gallon. To compute the ceiling quantity, I'm just going to take the supply function. Why am I taking the supply function? Because the ceiling price is going to come over to the supply function and drop down to give us a new level of demand or a new level of supply. Remember, as the price drops, the amount that the producer is willing to supply is reduced. So what we're going to do here is we're going to take 3 and set it equal to the supply function, which is going to give us 3 is equal to 2.1 minus 0.15x, and this x is going to be our ceiling quantity. We can go ahead and solve for x. We're going to subtract 2.1, and that's going to give us 0.9 equals, let's see, what am I doing? Oh, I know, this should be a plus. Oh shoot, it's not showing it. That should be a plus there. Equals 0.15x sub c. When we divide both sides by the 0.15, what we wind up with is the ceiling quantity is now going to be 6 gallons. Remember, when a ceiling price is established, the supplier is no longer willing to provide as much. At the equilibrium price, they were willing to provide each customer with 11 gallons per month. Now, with this new ceiling price of $3 per gallon, they're only willing to provide each customer with 6 gallons per month. So you see a reduction here in the service to the customers because of the ceiling price. Okay, so with this new ceiling price of $3 and the new ceiling quantity of 6 gallons, we can compute both the producer surplus and the consumer surplus. Let's go ahead and first compute the producer surplus. What's going to be the case here is we're going to have our ceiling price 3 times our ceiling quantity 6 minus the integral, and this time we're only going to go over to 6, so we're going to go 0 to 6, and we're going to integrate the supply function, which is 2.1 minus 0.15x dx. As before, this is what I'm going to be looking for on quizzes, tests, final exams. I'm going to expect this to be written out. Then I will assume that you can successfully plug this into your calculator. Make sure you can, okay? Practice them. Make sure that you can actually get this. The producer surplus works out to be $2.70 per customer. So notice that the amount that the producer is realizing as a surplus is significantly less than what they had before. Before, the producer surplus was about $9.08 a customer. Now it's down to $2.70 a customer. So they're losing a chunk of money here. When we compute the consumer surplus, once again, we're going to continue using this ceiling quantity of 6 and a ceiling price of 3. Our demand function is going to be 6.5 minus 0.25x, and we're going to compute our consumer surplus as the integral from 0 to 6, the x value, and we're going to put in our demand function 6.5 minus 0.25x, integrate with respect to x. We're going to subtract the revenue. The revenue is 6 times 3. Okay, here's the function, the equation I'm going to be looking for, quizzes, tests, final exams. And when you crunch that out, it works out to be 1650. Okay, so the consumer surplus is now 1650. There is, if you take the producer surplus and the consumer surplus, well, here, let's see. Okay, let's go ahead and do this deadweight loss first, and I'll show you what is going on. The deadweight loss here is the total amount of money that drops out of the system because of a reduced supply and an increased price. Okay, with the reduced supply, the producer isn't getting as much. With an increased price, or I'm sorry, with a decreased price, the producer is not getting as much either. Okay. Deadweight loss. To compute that, we're going to do the integral. Remember, we want this blue triangle. So we look at, okay, how far do the x values go? Well, they go from 6 to 11. And in any situation where you want the area between two curves, you always do the upper curve, in this case the demand function, which is the 6.5 minus the 0.25x, minus the lower function, which is your supply function, the 2.1, plus the 0.15x, Now, one of the things that you want to be careful of with the dead weight loss is that you take the entire demand function minus the entire supply function. Sometimes folks are real tempted to leave off this second set of parentheses, and if you leave those off, the negative only applies to the first term. We want it to apply to everything. Plugging this into your calculator, you wind up with a dead weight loss of 5.00 or $5. What this says is there's a total of $5 lost in the system as far as savings or benefit goes. Let's take a look at how this actually works out to the benefit and or detriment on each side of the ledger. Before the ceiling was applied, the consumer surplus was $1,530, the producer surplus was $908. After the ceiling is implemented, notice the consumer surplus goes up a bit, while the producer surplus is reduced dramatically. So when a ceiling is implemented, the consumers benefit to some extent, while the producer doesn't benefit at all. Now, when I say the consumer benefits to some extent, okay, they're saving some more money, but they're not getting as much of the product. Remember, they dropped from buying 11 gallons or having 11 gallons a month available to 6 gallons a month available. If you were thinking about this as fuel for your car and you went from having 11 gallons a week to 6 gallons a week, even though it's saving you a little money, I don't think you'd be real happy about the overall effect. So let's take a look here. We see that on the before-after side for the consumer, they gain a little bit of money. On the before-after side for the producer, they lose a chunk of money. If we look at the total amount of money in surplus before things were implemented, there was a total of $24.21 of surplus money in the system. Now, by surplus, that means that the producer got more, the consumer saved more. After the ceiling price is implemented, the total surplus in the system, the $1,650 from the consumer and the $270 that we just talked about from the producer, give us a total of $19.20 total in the system. Take these two values, take the difference between them, and we get $5.01. Now, where'd that extra penny come in? Because our dead weight loss, the net loss to the system, when we computed it was $5. Okay, this is our dead weight loss. This extra penny that we're getting now is the result of having rounded up on both sides. Remember when we did that? And we mentioned that there would be an extra penny come into play? Okay, that additional rounding results in this extra penny here showing up, which gives us $5.01 of dead weight loss, whereas in reality, it's $5 of dead weight loss. Am I going to be worried about 1 cent on a dead weight loss? Not at all. But what I want you to realize is dead weight loss is the total amount of money that drops out of the system because the price has been altered, either by setting a ceiling or by setting a floor. Okay, at this point, you have all the information you need when you combine the previous movie along with this one to do the section 5.1 homework in the My Math Lab. Be careful to watch the due date and the time. Okay, if you go past that time, you can continue working on problems, but there's a 50% penalty, okay, that cannot be adjusted once people start doing it. Okay, be aware of that. Keep an eye out for an announcement stating the day and the time for the quiz. I hope you're doing well with this, and I wish you the very best. Bye-bye.